Saxon Algebra 1/2 lesson 103. We're going to talk about the distributive property. This is a really great trick that we're going to use a billion times over. And let me show you how it works. Now, if we have all numbers, we don't really need the distributive property. Let me show you what it looks like. If we have all numbers, it's an arrangement like this. We have 1 on the outside and 2 being added or subtracted on the inside. Now this, we know we would do using order of operations, right? We would add those 2 together and we would get 4 times 5, and then that would equal 20, right? Easy. But let me show you another way we can get the same answer using the distributive property that's going to work a lot better when we don't have all numbers. If we had some letters mixed in here, we would need to do it this way. What we're going to do this time, it seems like we're ignoring the distributive property, the order of operations, but we're not. This is allowed. What we do is we say we're going to multiply this outside number times the first number and then times the second number. 4 times 2 is 8. That's a weird 8. 4 times 3 is 12. We add them, just as we were adding here. Okay, so we're doing a pair of multiplications. 4 times 2, 4 times 3. Notice the way I draw the arrows from the outside number to each of the inside numbers. That reminds me of which pairs I need to multiply. And then when we add 8 times 12, we get 20. Oh, it's the same answer, right? That tells us that this multiplying trick works just fine. And again, if we have actual numbers for all 3 of these places, we don't need the distributive property. We can just do it order of operations style and it'll be fine. But this I showed you just to prove to you it works. Because when we have some letters mixed in here and we can't multiply and get solid numbers, then we need the distributive property. So let me show you how it works, and then I'll show you the fancy formula that you'll write down and remember forever and ever. Ready? We have only 2 problems. And John, let me do this first. This isn't an actual example. So this is what I was talking about. Instead of 4 times the quantity 2 plus 3, we're now going to put letters in there. So we can't actually do the multiplications, but this is what we can do. I always draw my little, I used to call them whoop-de-doops. 4 times x is 4x. 4 times y is 4y. And we put the plus sign in between. Whatever was there goes here, okay? Unless there's a minus on the outside, we'll deal with that later. But remember that there's an addition or subtraction sign that belongs in here. That's our final answer. Notice that it won't work for order of operations because we can't add x and y. That doesn't work. So we can't get rid of the parentheses the old way when we have letters. All right, now we're going to do 2 examples. And just to make it crazy, John's putting 3 numbers inside the parentheses. It's going to look a little bit crazier, but it's not hard. I'm copying. Okay, you know you need the distributive property. Again, I'll remind you, when you look at the work inside the parentheses and you realize there's nothing I can do to combine those things because x and 2y and 8 none of them are like terms, so that's not going to work. So instead I go, I'm going to do the distributive thing. And again, these remind me, I don't always draw the arrowheads, but I always draw the little arches to show the different combinations I need. 4 times x is 4x. 4 times 2y is 8y. 4 times minus 8 is minus 32. There is my answer. And notice that the order of the terms, which we talked about in the last lesson, we talked about how we want to go from more complicated to less complicated. Here we don't really have to think about that. We just will end up in the same order that the terms were there, right? X and then Y and then plain number, because we multiply them each in order. So you don't have to worry too much about that at this point. And our second problem, second and final, Okay, this is what I was talking about. You don't have to worry about changing the order of this. Just leave it, and our answer will match up to that kind of, right? Because we'll just multiply each term in order. Okay, so this is what I do for every problem. I don't necessarily put the arrowheads on, but I always draw the little whoops to help me remember. 3x times y. 3xy. Minus, I'm going to write that right away, 3x times 2, that's 6x. Plus 3x times 2x. I do the numbers first. 3 times 2 is 6. X times x is x squared. And that is our final answer. And the order is fine, just the way it is. Yay! That, my friends, is the distributive property. We will be practicing it lots and lots and lots. Sometimes, usually, we just have 2 numbers inside the parentheses, but we can do 3 numbers. That doesn't bother us a bit. Just so you know, the way that we say this is 4 times the quantity x plus y. Parentheses trigger this phase. What's inside the parentheses is called the quantity. So we don't say 4 parentheses x plus y parentheses. We say 4 times the quantity okay? The quantity means what's in the parentheses. In this case, it would be x plus y. 4 times the quantity x plus y. I'm going to hammer that into you because I want you to sound smart. I want you to use words appropriately and accurately. Okay, now I'm done talking. 103 is over. Goodbye.